Good day, and this is one of the popular lectures which are located on my YouTube channel, which is called Knowledge is Strength. Knowledge is Strength in English. There are also some videos in Russian. I just, a few minutes ago, there was, I followed the lecture of Nobel Prize Laureate for this year, Professor Alain Aspect. And I did not go to Stockholm, I just followed it via YouTube. And I shall put the YouTube link. No, maybe it's not YouTube, it's Stockholm University link, yeah, but it's anyway, it's recording. I have not yet followed lectures of Clauser and Zeilinger because I followed the Bohr's ideologies. Each measurement changed the state of the system. Now I made just one measurement. I followed the lecture of Professor Aspect, and if I would follow the lecture of Clauser or Zeilinger, maybe my picture, my image of the lecture of Aspect would be changed. So just one portion, and generally, we should estimate extremely highly the contribution of these experimenters of Professor Alain Aspect and Zeilinger and also the works of Clauser to this field of quantum technologies, because it was shown that correlations between quantum systems can be preserved on very long time, on the very big distances. And this is the basis of quantum technologies. So this talk would be not against quantum technologies. It is not against quantum computer, quantum teleportation, and so on. This talk is about interpretation. And as this Nobel Prize closing all problems, preventing development of quantum technologies. So this, I would call this Nobel Prize the Nobel Prize for Quantum Technologies. But this prize did not close interpretation of problems. And as we see from the talk of the first speaker, and who did in fact more or less one of the first experiments with variable polarization beam splitters and so on. So Professor Alain Aspect, I totally disagree with his viewpoint. I would like to pay attention that his viewpoint was not changed for many years, because identical talk he gave at the conference in my town, Växjö, maybe 10 years ago, totally the same talk. It looks that Professor Aspect has very rigid picture of what happened. And this is a picture of really quantum non-locality. This is a picture of spooky action at the distance. More or less, this is non-local realism. I would think that Nicolas Gizan would be happy with this talk, but I don't know. In any event, roughly speaking, maybe in Växjö it was slower. It was practically 1 hour, and it was easy to follow this line of thought. And Professor Alain Aspect was not so formal. But it look, and even in this talk in Stockholm, you can see the following line of reasoning. And it is not in experimental framework. It is, roughly speaking, in formalism of quantum mechanics by itself. It's look, maybe I misinterpret. The problem of interpretations is very difficult. No, because, in this town, Växjö in Sweden, we have 22 conferences on quantum foundations, including Bohr inequalities. And even if you ask somebody and what interpretation of quantum state you use of quantum mechanics, and this guy reply you, I use Copenhagen interpretation. When you speak with him, especially if you have a bottle of wine, you immediately understand that this is not at all Copenhagen interpretation as it was in the mind of Bohr. And maybe if it is in the mind of Bohr, it is with some additional source and so on. So the problem of interpretation is very difficult, and maybe I totally misunderstood Professor Alain Aspect, both in Växjö and now in Stockholm, and also there is a beautiful paper, at least it is in the form of preprint, in the preprint on archive. It's called some kind of naive experimentalist viewpoint to Bell inequality, where this more or less stream of ideas is presented. The main problem is in projection postulate. And this is many people who work with quantum foundations know that projection postulate is very, very delicate thing. By this postulate, when we make measurement of a quantum system which has a state psi, immediately its state is projected onto the eigen subspace corresponding to the value of the result of measurement. And now if you have the state of compound system, and if you make measurement on one subsystem, immediately the total state of compound system is projected to a very special subspace. And in this subspace, if the initial system was in the correlated state, so if here was spin up and here spin down, if you know that in this place spin up, then immediately we shall get to know that here is spin down. So in some things, this look as non-local effect. But, and it is Alain Aspect told this in his lecture, that this non-local effect, of course, can be explained by correlations, because this compound system was prepared in one state, and then when it moved to the distance measurement here and here, it is just exhibition of these correlations. In this modern time, in this last lecture, there was even remark that this is more or less as two COVID. We found two COVID patients who in different hospitals in different countries, and if you know that they are twins, maybe there would be many similarities in this story of the illness. But then he continued, and this is the right idea that let us try to test this idea, that there exists some hidden variable, the correlation which determines our outcomes of measurements. And this is he coming to great contribution of John Bell. If I spoke with so many people, if I rightly understand situation, Bell from the beginning, he was realist. He wanted explain the quantum mechanics in the classical like way that there exist some parameters which determine outcomes of all measurements. And more or less the violation of his inequality was he did not wanted this. If you read even his book Speakable and Unspeakable in Quantum Mechanics, you will see that he tell, okay, the life is such complex that we should accept that we cannot introduce these hidden variables because they introduce this spooky action at the distance and quantum non-locality, or we should accept this quantum non-locality or give up with these hidden variables. This was the line of discussion, and it looks that if you follow discussion lectures of Alain Aspect, again I'm sorry if I misunderstood him. It looks that he is on the point that there is non-local action at the distance, and this non-local action of the distance explains violation of this Bell inequality. My viewpoint is, in fact, I follow in some way Bell. Recently, I did not read this, but recently Richard Gill, in his email to me, pointed that maybe he knew this better. At one occasion, Bell told that if Bohr would follow the talk about Bell inequality and its violation, he would tell, yes, we know this, it is not surprising for us. And also Richard wrote me that at some occasion Feynman was asked about Bell inequality, and he told, yes, we knew this for long ago. We knew this for long ago. What was if this story is correct? I neither read concrete citation of Feynman nor Bell about possible Bohr position. But I totally agree that position of Bohr would be, yes, it is clear. It is clear. There is no problem with this. Why? Because for Bohr, from the very beginning, quantum mechanics was more or less constructed against this possibility to introduce the hidden variables, to determine outputs of measurements by some parameters which are associated to only this system. Because for Bohr, and here I would like to thank my good friend Arkady Platnitsky, who wrote many books about this and who told me this is in many times in very details. For Bohr, the outcome of a measurement, it's not something news. I was just uneducated, and I thanks for education. Yes, that outcome of measurement is the result of very complex process of interaction of subsystem and measurement device. So therefore, outcome of measurement is not associated with system. This picture, and we can call this contextuality in modern terms. It's not this very special contextuality which people now discuss, joint measurement contextuality. But contextuality, Bohr did not use the word context. He used the word conditions, experimental conditions. So one should take into account the whole complex of experimental arrangement. Maybe he wrote this one. So then coming the question, if the outcome depends on context, on measurement device, why should we accept that all measurement devices can be unified in some joint context, joint measurement context? And of course, in fact, this was initial point of Bohr's problem, because it was the Heisenberg uncertainty principle. Yes, when position and momentum, if we follow the reasoning of Heisenberg's microscope, of course, some people would criticize this, and the critical remarks have grounds, but nevertheless, position and momentum, it seems that two contexts, experimental arrangement for measurement of position and experimental arrangement for measurement of momentum, could not be unified into one experimental context. So this is the essence of Heisenberg uncertainty relation, which is represented in the form of Schrödinger-Robinson inequality for general observables. Okay, so this is Heisenberg story, Bohr story, and now from this Bohr came to ideas that there exist incompatible observables. Observables which experimental context interactions with measurement devices cannot be combined in a single experimental arrangement, into a single experimental arrangement. And from this we have non-commutative operators, we have and so on and so on. And now we're coming back to Bell experiment, before to go to this incompatibility picture, I would like to make one remark which is not so well known to majority of people who work in quantum foundations and who work with Bell inequality in the CHSH form. If we consider this inequality, there are 4 observables, and in fact 2 for Alice 1, Alice 2 observable, and 2 for Bob 1 and Bob 2 observable. And in the experiment we measure correlations. There are in fact 4 experiments. So one should have in mind that Bell experiment is not one experiment. These are 4 different experiments. Of course, they can be mixed through some random generator, but nevertheless, there are 4 different experimental contexts. For example, and we can select one for Alice and one for Bob. So we have correlations between A1, B1, A1, B2, A2, B1, and A2, B2. So we collect all these correlations. Now, let us try to write these correlations purely in the quantum formalism. And then put them, express these correlations which are present in the CHH, Clauser, Horny, Shimony, Holt inequality, but in the quantum formalism. And we shall see that here appeared surprisingly commutators of two observables for Alice, the product of two commutators, and observables for Bob. So commutator A1, A2, and B1, B2. And Bell or the CHSH inequality can be violated only if both these commutators are non-zero. So, but non-zero commutator means incompatibility. So two observables of Alice should be incompatible, which can be selected by Alice. And two observables by Bob, they also should be incompatible. Otherwise, it is not violated. We see, and this is coming from, I think, from Landau, Landau identity. Or it was in the paper of Landau. In this place, I am a bit tired and I forgot. I will make citation to my paper where I get rid of non-locality from quantum physics, where this is written in very simple form. So we see that there exists really connection between incompatibility of observables and violation of Bell-type inequalities. So if all observables are compatible, it cannot be violated. It cannot be violated. So it looks that one of the sources of violation of Bell inequality is really incompatibility. The impossibility to unify these four experimental contexts in one single experimental context. But this was known for Bohr, Heisenberg, Schrödinger, and so on from the very beginning. So, from my viewpoint, and this is my personal viewpoint, which is of course has not the aim to diminish the great role of these experiments, the role of experiments, but this is my contribution to interpretation, and I have the right to make this contribution. So from my viewpoint, the problem is in incompatibility. The problem is not in non-locality. And from this point, and incompatibility is not only the feature of compound system. So incompatibility can be observed for a single system, and this is also not a problem because people, for example, may be stimulated by Adam Cabello in Vienna, in Atom Institute, Helmut Rauch and Hasegawa, they did experiments on quantum contextuality for a single neutron, which also violated Bell types inequality. But what they tested? They tested, in fact, incompatibility of observables. And now we see that the main message which was sent by Bell and by these experiments to quantum foundations, that this is elaboration of very good and very well-established test of quantum incompatibility, because, and this is good, this is very important, because I wanted to find the ways how to measure commutator multiplied by I. And I have so many friends and nobody can tell me how make I have two observables A and B, and I want to know, I want to measure observable I, the commutator. Some people around Aronov told me that you can try to use weak measurements and so on, but it looks that this, if we interpret violation of CHSH inequality as the test of there are two pairs of observables of joint incompatibility of these two pairs, then it is very good interpretation, which is not mystical, no spooky action at the distance, no quantum non-locality. So it is the beginning of quantum mechanics. And this is the good place, and this is the good place to go to this beginning of quantum mechanics, which is practically forgotten. and try to understand how Heisenberg and Bohr, they try to justify the complementarity principle, existence of incompatible observables. And this was related to existence of indivisible quantum of action, to the Planck constant, that we cannot make distribution and we cannot make disturbance less than this given by Planck constant. Therefore, we cannot find really objective properties of quantum objects. So we found only these properties which context dependent, which depend on the total experimental arrangement. So the essence of quantum mechanics is in Planck constant. And in this great day of lectures of Nobel Prize laureates for Bell inequality, which is of course also Nobel Prize for quantum foundations, independently what kind of interpretation of this result you present. In this day, I would like to attract attention of the whole quantum community to the Planck constant, because it looks that Planck constant, what is justification of its existence? It seems that nobody knows this and nobody tried to do this. I read recently some paper of Niels Bohr. It was about biology, I think, and here he told you it's just Planck constant, it is given by nature. So nature is such that there exists Planck constant. But can we explain what is behind this existence of Planck constant? Then we would explain why we have these incompatible observables and why we in fact violate Bell types inequality. And here no Spocky action at the distance, no quantum non-locality would be attracted. A few minutes later, I shall record another video where I would like to give some, I can say, jokey illustrations, but maybe really reflecting the situation of incompatibility. That incompatibility is not something very strange and so roughly speaking, so maybe incompatibility is not really reduced to Planck constant as was in the mind of Bohr. But in any event, for this moment I finished. So I disagree totally with interpretations of violation of Bell inequality with this quantum non-locality, blah blah blah, spooky action at the distance, blah 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 blah. We go back to our good father of quantum mechanics, to Niels Bohr, to impossibility to separate properties of the system from the measurement device, from experimental arrangement, to existence of incompatible observables, to Heisenberg inequality, and to Bell inequality as a new expression of the Heisenberg inequality. All the best and bye-bye.